Okay, so, problem, right? Okay, so 2.7% on the high end and 2.7 on the low end. That will be this graph right there. Okay, this StatCrunch, stat, calculators, normal, and leave mean and standard deviation the same because mean is 0, deviation of 1. And then like cutoff values, the z-score is what you're putting in. The z-score is so that's a 0.027. Convert the percentage to a decimal. And that's your answer for both of them. Be negative 1.93 because you got a round, and then oops, there you go. That's question 1. Question 2. This one is between same calculator, the normal one. Go to between, leave mean and standard deviation the same. If it doesn't say they're different or declare them in any way, just leave them the same. You put the two z-scores there. These things between, and then this is your answer. So that's a percentage in the answer. So you convert the decimal, that's 99.95. Question 3. And this symbol means mean. This symbol means standard deviation. And like the default mean and standard deviation is 0, 1. Okay. And then for this problem, you can read it, try to figure it out, but the answer is this. The z-scores are numbers without units of measurement. I think that's usually the case. Okay. Question 4. This will also be the normal calculator. I think you're just doing, yeah, it's just standard. So this is a very easy problem. The average, the mean is 266. Standard deviation is 15 days. And you want to find the probability of it lasting 308. So greater than, because you want 308 days or longer, greater than or equal to. 308 goes there. Oops, no, it doesn't. My bad. 308 goes there. And probability down to 4 decimal places, so 0.0026. It's 4. Yep. On or before. Oh, this is question B. Lowest 4%. So, an easy way to figure out where to put the 4% in this is 308 is the days, and this is the percentage, and it gives us the percentage in the second part. So clear that, the days, clear the days, put in the percentage, 0.04, and that's the amount of days. Round to the nearest number, so 292. Oh, it's less than 240. We round. There you go. And the reason why it's less than is because it's just the lowest 4%. So question 5. I believe this will still be normal calculator, but go back to, oh, yeah, standard. Okay, oops. Well, the mean is 76. The standard deviation is 0.5. If one adult female. So I just did questions 1 through 4, but now for the rest of them, I'm figuring them out as I'm recording, so it might take a little bit longer. I'll pause it while I figure it out. Okay, so probability, it's the same calculator. You just go to between, mean, standard deviation, and it's find out what the pulse rate is between 72 and 80. So put 72 and 80, compute. That should be your answer. I haven't tried it yet. 5, 1, 0. That okay, cool. 4 females are alright, I don't know, I'll pause. Alright, I got it. I just found out by looking at the example and staring at it for 10 minutes. But anyway, you so there it says 4 adults. You take the standard deviation and you divide that by the square root of n, which is this. So that will look like, no, not bad. Freaking paint. I'm like a math teacher, look at this shit. By 4, that's what you're doing basically. And then you take that answer, you put it in there, leave everything else the same, and that's your answer. So, because square root of 4 is 2, 6.25. There you go, see, like that. And then that's how you do it. So always when this problem comes up, if it's like, say, 6 adult females or whatever, it'll be the square root of 6, and then 12.5, or whatever the standard deviation is, divided by the square root of 6, whatever it is. And put it on the standard deviation, and then you're straight. You got it. And why can the normal distribution be used in part B, even though the sample size does not exceed 30? Now, I don't know what the hell this means. I'm going to pause it and figure it out. Okay, figured it out. The answer to C is, why can the normal distribution be used in part B, even though the sample size does not exceed 30? The sample size is 4. It's because it originally states that they are normally distributed, so you just say that. The original population has normal distribution. There you go. Question 6. Let's see what we got. This looks like another normal calculator, but in standard. So 100 for the mean, 15 deviation, randomly selected adult. Actually, that's in between. So 80, 120, round to 4 decimal places. 8175. Oh, that was it for that question. I mean, that's basically question 4. Alright. Question 7. Ooh, cool. Question 8. A magazine provided results of 2,000 adults were asked to identify their favorite pie. Of plus 4%. Oh, this is just a statement. So, the margin of error was given as plus or minus 4 percentage points. I think it'll be this, let me read first. No. 11. It should be this one, because it's just common sense, I believe. Plus or minus 4%, it's pretty self-explanatory. Properties of margin of error. I was very wrong, look at that. I think it's that one. Yeah. Yeah, I remember in class, even the professor was like, this question's kind of loaded because I'm pretty sure this is technically correct too, but for some reason they want this. This statement indicates that the interval 11% plus or minus 4% is likely it's just the word likely, I think. It's not 100% sure. It's just likely. So question 9. Find the critical value corresponds to the confidence level 7. Okay, so this is no longer the normal calculator. Let's see if I can find this. I think it's one of these two. What is the variance? Oh, I don't think it was this. Let me try to remember which one. Okay, I just looked it up on YouTube. Apparently it is still the normal thing. Normal calculator, I mean. And you go between, leave everything the same, but except this. That is the confidence level. Just put that into percentage, and there's your answer. This thing, the critical value thing, is 1.6954. Oh, I'm sorry, I guess 1.7. Yeah, that's very general. All right. Question 10. Okay, boom. Ready. So for this one, it's not normal calculator, it is stat proportion. Because proportion is a synonym for probability. And we're dealing with the probability. Like, what's the probability that many babies are whatever? So proportion, one sample, and then with summary, because this is a summary, not a bunch of data. And then, so total 375. That'll be the number of observation, 375. And then 300 of them were females, 300 were girls. And then use this up. A confidence interval of 99% compute. So the lower limit will get over here. There we go. 3.7. Okay, 0.747. 853. Okay. Yes. I mean, that's just, you can look at this. You have 300 out of 375. That's a lot. Yep. Oh yeah, and I think it's why it's saying is different from 0.5, if you even care, is because it's around 50-50 of like babies being born whatever gender. And then yeah, it differs a lot from 50-50 or 50%. Right, next. Oh, I should pause.